now for our last speaker, we have Aaron Trocola, who is the bomb designer. And he designed headsets for OpenBCI and many, many other wearables that work with computing. And he has a special demo for us tonight, from what I've seen, that is really going to be great. So, Aaron Trocola.
Thanks. Well, my demo person actually had to go, so hopefully some people saw it before, but yeah, she had to leave. Anyway, all right, so my talk is about digital representations of the body and how that's going to sort of evolve in the future. Right now, we have a lot about the mind that we discuss and making models of the mind. And everyone knows about the singularity, the favorite idea of futurists. Eventually, you'll be able to just upload your brain into a computer and your body won't matter, and you'll just kind of be a digital human at that point. Well, I'm going to sort of address a different topic. I mean, that's kind of far-reaching for me. And here I want to focus on your actual corporeal body, because I believe there is a value to that, and a representation in the computer is important, but it is not actually you. And I do make that distinction. But what there is there's a dialogue. You've got an input and output into this digital world using 3D scanning to capture your body shape. And now with 3D printing, we have a fairly intuitive output method. So I sort of describe these as windows into and out of the digital world. And I'm mostly going to be talking about the process and the challenges, but I also want to do a little bit of speculation about where that's going to go in the future. Yeah, a little bit of structure, so because I'm going to have to come back around. It's going to be a bit of a loop because it starts with volumetric imaging, which is sort of a medical context, but then goes to surface scanning, because that's more common now. That's what we use for VR, and it's accessible. You can buy a scanner. You can't buy an X-ray machine very easily. But I'm going to come back to volumetric imaging at the end to emphasize how important that is, and as these technologies develop, how that's going to actually be used to leverage the real kind of panacea, the ultimate goal that we're heading toward with this. All right. I got my start using volumetric imaging while working for a 3D display company. One of the earliest projects that I made use of, I wasn't directly involved in the Visible Human project, but this is a very early example of a very complete digitization of the human body in a volumetric way. That is, not just on the surface, but all the way through the body, using MRI and CT and physically destructive scanning on this one example of a human. And that was used for a lot of surgical training data. They eventually divided the entire thing up into polygon meshes and archive that you could buy, and then you could use to develop your own software. For my application, I was working on a 3D display system. This is a dinosaur version of that machine. This is about 15 years ago, in the late 90s, early 2000s. We developed a surgical simulation system for DARPA, which essentially would take that volumetric data, and the idea was that you would be able to perform surgery on a digital representation of a person before you would try that in real life. A little bit like they do with medical modeling now. You'll 3D print a tumor or something like that for visualization purposes, but this was actually simulating. Unfortunately, the technology was barely good enough back then to hold something in video memory, like a volume image in video memory was very, very difficult. Now it's much easier. We're going to talk a little bit more about the data size problem a little bit later, but that was kind of my origin, and I've stuck with that idea, but expanded that to look at not just medical applications, but our day-to-day life and how that's going to affect how we live moving forward. So these are examples of 3D printing made from volumetric imaging of the body in one of the more popular applications. Because it's so expensive in medicine, we can do this. And this is about as far as we've gotten with it. It's all made of titanium because of the biocompatibility aspect of it. And it's increasingly popular, but it's not something that is going to affect you unless you have an acetabular cup, or if you get your hips done or your knees done or something like that. That's actually pretty common to have the interface between the standard thing and your unique human body to be this 3D printed thing. So that's volumetric imaging and medicine. Want to shift gears a little bit to surface scanning, because this is more part of our everyday life. This is what we do when we're building avatars for games and movie production and things like that. In my case, I'm applying this to wearable technology because the core idea I want to bring out here is by using the 3D printing approach, we can then make products and stylized wearables that are actually custom fit based on that data. And so this is going to be kind of a feedback loop, is the idea that we're going to build a representation of ourselves digitally, modify that, print that out in real life, and then now that's you in real life. So I'm going to cover a little bit in applications. The main one I want to focus on right now is VR and AR interfaces, basically using this data to generate arrays of sensors on the body so that you can have a natural interaction with your VR setup. And so that can be by recording your muscles and emotions as an actual interface instead of a mouse or the glove, the classic glove. So to go into a little more detail about how this is done, I'm just going to briefly go through a few slides. I don't want to drag out the talk. This is structured light 3D scanning, where essentially a fringe pattern is projected, and we use a frequency analysis to get the data from each pixel. Basically, it's a range image for each pixel. This is a industrial inspection system, so it's very, very high res. And then once that is in the computer, we can offset the surface, and those layers become their sort of own independent space that you can work within. So it's sort of a two-dimensional surface that's stretching around these curves that you can then design just as line work, sort of like circuitry. You know, you can conform that line work to the surface. And so I've made a lot of examples of that as some more artistic sort of performance gear and things like that. There is limit when you're talking about eventually moving toward more functional things. There's some legal obstacles. Basically, you can't sell anything that's going to require FDA approval if you're going to remake the entire thing every time you do it. You've got to go through a long process. So the legal issue is one problem. The technical issues are more fundamental, and those we've made a lot of progress lately because of the big push in data, any kind of data, just through Google and some other recent companies pushing that. I'm going to talk about one in particular in a second. But the issue of just taking a 3D scan and using it is based on the fact that you've got a random, unstructured set of data, and you need to find kind of correlations between it so that you can do something with it, so that it becomes an intelligent data set rather than just an array of points. And so that's on the far end, we've got 3D scan data, which is millions of points, and then on the quantified self end that we normally use in wearable technology, you've got tiny, tiny, tiny bits of information, you know, heartbeat or number of steps or something very, very simple like that. And there's a huge gulf in between that where we don't really have the technology to make much use of all of that data because, you know, most of the microcontrollers we're wearing have a few kilobytes of memory. It's just not going to work with the body, not with that type of data yet. We're right on that line. And then there's the cost of production, some other issues like that. One I'd like to talk about in particular, I mean, it's beyond the scope of the talk, but maybe afterward if anyone wants to discuss this, the miniaturization of electronics and integration of that within the wearable technology stuff, super important. In the same way that our phones are portable computers, once that gets to a tinier threshold where you don't have to take it out of your pocket and look at it, and you don't have to have a screen and a battery, it become sort of immaterial and mixed into whatever products you're wearing. And then so the physical manifestation of it can be virtually anything. Just like your phone, the appearance of the phone on the outside doesn't matter that much. What makes it what it is really the software that's running on it. And so that type of liquidity is going to happen with many more physical products that we interact with, basically treating hardware like software. Let's see. I'm going to go into the problem with tracking the body and structuring. I want to basically say that when you're talking about sensors on the body, putting them just in clothing is a huge problem because everything moves around. So we don't have point-to-point correspondence. And that's what we gain through the 3D scanning and actual knowledge of the body when the computer and the software in it is conscious of where your body is and each point on the body. Suddenly everything becomes much, much more functional. So in an effort to do that, Hollywood was way ahead of all these other technologies because they did a lot with motion capture and rigging and basically taking that scan data and making it into something that works, that you can use. So they were doing that in the late 90s, and it's only recently moved forward where we took this type of technology, which is basically generalizing the shape of a body, then identifying the pose, and then basically regenerating that avatar in a neutral pose. That means you can take a scan of someone in any position, find the shape, reorient it into a neutral position, and now you have a mapping from that individual to a generic human representation. And that means you now have a key that basically means you can transfer data from one person to another. So what I mean by that is if I make a custom outfit or product for myself, it is custom fit to certain anatomical reference points. Using this system, that can now be translated to another person who is much taller or shorter or bigger or smaller with perfect point-to-point anatomical correspondence. And the company that was making the biggest effort toward that is Body Labs downtown. Worked with them a couple of years ago. Made a big data set with a few dozen people that I was working with. Their system doing that can generate what you see on the right. That is not a scan, that is an avatar generated from a scan. So that person was not in that actual position when they were scanned. This Excel spreadsheet with all those numbers was generated automatically. So the main application for that company is clothing customization. That's the low-hanging fruit. They were just bought by Amazon for about $50 million, and so very soon you're going to be able to go shopping online, and instead of returning 30% of the clothes you buy, you're just going to stand in front of a sensor, like their 3D webcam, scan your body, and then that will modify the clothing automatically. So that's a few years out yet. They've been working on it for a couple of years. Some of what I've been doing in my work was to use anthropometrics based on scans to customize or semi-customized products for ranges of people. So I can take, 3 or 4 people who are similar and average them together. And so what Body Labs has done for the surface of the body, for clothing, think about that, take that another step further and look at what that is going to imply when we apply that to volumetric imaging. So instead of a mesh of polygons, a bunch of points, you've got a stack of images like a CT scan or an MRI. Big problem right now is identifying those landmarks and boundaries on the inside of the body. So this isn't a new thing by any stretch. Everyone's very excited about big data and machine vision because so much progress has been made in the last year and last couple of years by Google and others who are working on it. But this is not a new thing. This is more than a decade old. The National Alliance for Medical Image Computing has been working on the volumetric segmentation problem for a long time. It's more than 100 universities. Some of the smartest people in the world are working on it. So definitely not a new idea, but it's just now reaching that threshold point where radiology done by a machine is as good or better than radiology done by an expert person. And it needs less and less guidance. And so Body Labs could rig a animated model, but that's just by analysis and statistics of the surface. Imagine what you would get once you're analyzing the actual internal structure of your body. The advantage of those things that I'm making that are matched to the surface of your body is that it's, for example, distributing pressure very evenly. So if you're wearing a product that is semi-rigid, let's say you're carrying something, by having that conform, you're going to have a much more comfortable experience. And by analyzing the motion, you're going to have a much more comfortable dynamic experience. The motion, I think volumetric analysis of motion is not happening very much yet due to the fact that X-rays create a lot of radiation, and we just now have X-rays that are sensitive enough to make a X-ray animation. GE just launched that. If you Google that, you'll see some nice GIFs of beating hearts and things like that. All right, so I'm going to quickly talk about a specific example because this has all been kind of just imagery of the data rather than what you do with it. So I want to talk about project work together with OpenBCI, as Alan said. I do this surface scanning and kind of performance-based stuff that's a little less, more distant from medical. OpenBCI is also not medical, it's research, which is, again, how we're kind of skirting the laws regarding medical devices and FDA approval, but still a very useful tool. So if you're doing research, and you can use it as a game controller and things like that, but for people who are using it themselves, the implications are much more serious when you're talking about people who are paralyzed being able to operate their computer and so on and so forth. That's the promise of the EEG system, and this initiative with OpenBCI was to create a headset for an EEG that is a fraction of the price, maybe about 5% of the price of a medical grade EEG, but still has the same quality. And in an effort to do that, we decided to scan a lot of heads and make an anthropometric data set of crania and basically analyze that and average them together. If this were actually PowerPoint instead of OpenOffice, you'd see a nice GIF animation of it morphing between some different heads, but you'll have to use your imagination. So that was that project. That's an older version of the thing. Moving forward, we decided to make everything using 3D printing to keep the costs down. There's a nice solid community growing around this, and new versions come out every day. In fact, this Kickstarter just launched, delivered earlier this year. In, I think it was February, we shipped a few hundred of these headsets to Kickstarter backers. So that's the old version. Yes, it looks very strange. This is not perfectly custom fit, so it needs many accommodations for adjustment. If we were making it for one specific person, if anyone would like a specific one, I can do it, but there's labor involved because that whole system is not automated. We have tools like Body Labs that get us closer to automation, but essentially what happens is the problem comes down to you're writing a program just to make a product, and you need to have a certain number of products for that to make sense. So that was the M4 there. It looks better, but still looks pretty strange. So this is one of the issues I want to talk about. When you're making products that are based on anatomy data and not on aesthetic choices, it's sort of generative, and you can nudge it this way or that, but it kind of is what it is. And in the early stages, we're going to have to get used to this. We're going to be exposed to some really strange events. And this is already happening. If you look at some of the Google deep dreaming results coming out of AI, some of it is seriously strange. But yeah, nudging it a little toward the creative stuff, I am able to make it look a little more aesthetically pleasing. This device was done for a movie, so it's not functional. But we're still going to have this kind of interplay for a while, where you're going to have to put a layer of aesthetic choice over the function that is generated by the automated systems. And that's going to be more and more possible as the devices shrink. So here's a more aesthetic, miniaturized, like these only have a couple of sensors for an EEG. It's not very impressive, but a little more acceptable to wear. And then on the other end of the spectrum, this one is really strange. If you thought the ultra cortex was weird, this is the myomask. It's putting electrodes on the face so that when you move your face around, it's measuring all your muscles. Look at this guy. That's pretty crazy, right? So we know what it looks like. It's pretty unusual. And right now, actually, what is it called? Mindscape. Company just got $108 million to put sensors around the face for VR. They don't do the lower face because it's just not something you can wear on a day-to-day basis. So the more aesthetic examples you're going to see of 3D printing stuff generated from body data are in some of the wearable sort of fashion pieces. Unfortunately, not very practical. The materials aren't quite there. They look interesting when you have these faceted tiny pieces, but that isn't very functional because they actually have a lot of sensitivity to point impact and point damage. So that means if you snag on something, you're going to damage that, and now you can't fix it. You have to reprint the entire thing, and it takes weeks, could be thousands of dollars. So a few more examples of anatomically generated models that, again, pretty odd geometry that comes out of these things. Just looking at what comes out, I think it reminds me a bit of internal organs. You know, it's got that sort of organic look to it where everything's sort of wrapped around, but that's not what we're used to seeing. For stuff that comes out of the human mind, it tends to be fairly rectangular. You know, you might have a little bit of curve here and there, but not nearly so organic and blobby. This is an example of using that approach of the generated structure on the body scan, but this is just taking that idea from the ultra cortex of the array of sensors and generalizing that out to the rest of the body. So you can imagine down the road a little bit in a few years where these systems are becoming mature, you can pick which sensors and which inputs and outputs you want and pick which parts of the body based on some criteria, and it will just be generated. And you know, take that a step further. If we're going to be able to print wires and tubes for air and cooling and liquid and things like that, all just generated, all printed at once, and then so what you are wearing is not a shirt, it's not a computer, it is a device which is perfectly tuned to a function and automatically generated. So as this moves forward, we're going to see sort of an ecosystem develop around this, I like to say. And what I mean by that is when you think of mobile, we put these in our pocket so that we could communicate. And yes, that's a major important role, but what happened after that was totally unexpected. Even the people who made the iPhone, they knew some of the implications, but no one could predict what apps are going to show up and how people are going to use them. It gets pretty complicated. And so I'm looking forward to seeing some emergent applications that are less intuitive. There's going to be some issues with privacy. So again, you're going to be carrying around a digital version of yourself. It may be stored in the cloud, and it's got everything about you physically there. So that could be, it could open you up to discrimination if you've got a disability, for example. Definitely your insurance company is going to want a copy of that. And so, yeah, that's dangerous. Considering basically everybody gets hacked all the time, the implications of that are still pretty unknown. But to be a little more positive, looking at how that's going to go further, basically you'll have to wear less silly things, less bulky things, and it'll be a little more intuitive to interact with that digital world. Your representation of yourself digitally in VR may look a little bit stylized, but well matched with your real self. So you can have your, you know, altered shape in VR match your real manifested reality shape. Unfortunately, our actual selves are not necessarily ideal, so that's not what everyone wants. But as technology moves forward and we can modify our real actual selves, then you may get what you want. So talk a little bit about motion capture. Basically, we want to get rid of the heavy headsets and things like that. And I basically see this being a more unified approach where our sensors, if they're part of our clothing already, we don't need to put on this complicated getup to do motion capture or to interface with our VR systems. Should be just very natural. So in the future, I expect all of us to have our avatar, but not just an abstract avatar, an avatar of ourselves. As opposed, as a kind of counterpoint to that idea of singularity where your brain is going to upload into the computer, I don't quite see it that way. I'd rather look at it as a digital double. So that digital double may possess a model of your brain built from your interactions, but that's definitely not you. And you may have a digital double that is based on your real representation, also not you. The problem then is when you're interacting online, how do people tell the difference? Well, it's going to be really hard. We're going to have real-time scanners so that when you're talking to your friend over a distance, it's going to be possibly a hybrid between your avatar and your 3D video when you're interacting through VR and AR. Let's say in the context of a meeting or a social media, when we have real-time scanning happening. But you could suddenly take off that outfit and move out of the picture, and your AI could just keep the conversation going. The person you're talking to would never know the difference. So issues pop up, and it's kind of a creative challenge, and I'm looking forward to seeing how that plays out. I'm happy with the role I'm playing in this kind of physical manifestation of this stuff, and I look forward to having my own avatar of basically a digital double of an ideal self, and I think we all will in probably less than 5 years. So any questions about 3D printing in the context of the body, digitization of the body, and how this will evolve into an ecosystem? Go ahead. Yes. This is part of so I'm going to body hacking conference in a couple of months, and everyone there is way into that idea. They want you to do surgery and modify yourself to become a cyborg, to make yourself into your ideal self, physically, really. I'm not incredibly enthusiastic about surgery because there's a percentage of failure and you might do more harm than good, and there's all these ethical implications. There's a lot of discussion and, again, legality issues that we have to sort out about that. But there isn't many legality issues about what you do to yourself. And let's say you program a robot to do the surgery or something like that. Well, no one's going to stop you. I'm a little leaning more toward robotics. Yeah. I've seen a couple different suits. Xsense has one. So issue with that stuff is they're all $30,000, and it's great for movies, but it's not for you and me and people just walking around. It's not quite appropriate. Right now, the better solutions are remote sensing. So a real-time 3D scanner like Kinect, but a little bit better resolution. So yeah, in the back. Yeah. Yeah, I think I saw that demo. So was that an organic muscle or a polymer? So, yeah. Again, it's not quite my area. I'm more into polymers and synthetics rather than actual surgery. That's a personal preference. I do imagine with stem cells and everything, you could redesign your body, edit your DNA however you like. All of that is kind of speculation at this point, but those examples of training a batch of muscle cells to move and hypothetically implanting it, that's a step toward it. But I don't necessarily want to be a cheerleader of that idea. It's already been explored a lot in fiction and in conversation, and we're gonna gently move into that. Long before then, we can just take something on, put something on, and take it off, and not endanger ourselves. and not make permanent changes. And I think that's a little bit safer, creative environment for us to explore these ideas before we go performing surgery. We'll be able to do this cheaply as well. So any other questions? I don't want to hold you here. I do want to talk more about, for example, the Raspberry Pi. Google just released a hat for Raspberry Pi that has an AI chip in it. Related to this because, again, wearable tech and miniaturization of electronics, but I don't want to hold you all to that since it's beyond the scope of my topic.
Yeah, let's end this now and the stream, and then our guests will be here, and you can speak with them privately. So thank you so much. Okay.